everyone. Thank you for coming. Wow, what a name for this track, huh? Old school languages still rock. Jonathan said that I'm old school. I guess I should explain a little bit about what that means. I'm currently the vice president of the Java Platform Group at Oracle and also the chairperson of the OpenJDK governing board. By way of background, I've been working with Java since probably 1996. I joined JavaSoft when we were about 35 people in the development organization. And I did my first code was in AWT in JDK 1.1. I was one of the founders of the Swing group. I named Swing, for which the marketing people have never forgiven me. And started a little project called WebStart and did a few other things. Ended up leaving Sun, doing a couple of startups, which you'd never heard of because they weren't very successful. But then I worked for BEA and ran the JRocket group, and actually came into Oracle that way. And so when Oracle acquired Sun, someone up there at the top said, hey, wait a minute, our guy who runs our Java thing used to work with all these Java people at Sun. And so we were reunited, and it feels so good. Sorry, I had to get a little old school in there. That's all right. For the younger folks in the crowd, that's like an old song you never heard, so don't worry about it. It's all good. I will, so anyway, I've been doing that then since about 2010, and we've actually been making a bunch of changes since then. And so I'm going to talk a little bit about what we've been doing in order to make sure that the old school language of Java still rocks and is going to rock even more going forward. But first, since I'm from Oracle, I get the pleasure of showing you guys this slide. All right. So all those huge purchasing decisions you are going to make based on what I'm saying, don't base it on what I'm saying. All right, so 20 years is kind of where we are. We're actually past 20 years now in Java's history. And I'm really pleased to say that the Java ecosystem is huge. It's really thriving. There's a lot going on. One thing I would point out for any of you who are not familiar with it, the CJUG here in Chicago is tremendous. They have all kinds of meetups. If you have questions about it, I think some of the folks who lead it are actually here in the room today. And they also have great stickers and T-shirts. Now, I would have worn their T-shirt, but they haven't given it to me yet. So they're going to fix that, they tell me. We'll see how that goes. So other things that are kind of going on. In addition to the user groups, there's a program called Java Champions, and we have a number of those actually at the conference here today. Those are folks who, throughout their careers, have kind of helped make Java what it is today. And so those are great folks to look to in order to sort of ask advanced Java programming questions, what to think about, and how to, what kinds of projects are happening that are interesting that you might want to know about and get involved in. There's a great thing called the Java Magazine. If you haven't seen this, please check it out. It is a beautiful, beautiful digital-only magazine, which comes out, I think, monthly and has hundreds of thousands of subscribers and has some really, really great articles in it. So check that out. And then finally, OpenJDK community itself. What I will mention here is that this is where everyone who is sort of leading the future of Java comes together to work on the design and the implementation of future versions. Now, the neat thing about this is all open source. You can download all the source code, both for OpenJDK and for a number of projects that have not yet made it in. And you can see the design decisions happening. You can see the discussions between the leading engineers. You can see, you can ask questions. You can also see all of the code reviews as those are happening. And so this is a wonderful way of getting insight into the direction and also understanding the trade-offs that are being made by people and why maybe one design is chosen instead of another. So do check that out. So Java continues to grow. It's interesting, we've seen a lot of shifts over time in where Java is most popular. You may be familiar that early on it started as this cool thing where you could have like a tumbling Duke in a browser. And in fact, it ended up taking off a little bit on the client, but actually mostly on the server side. And so with the growth of Java EE and so on, that's kind of where it became huge. It also is a lot larger than people probably realize in a lot of embedded environments. We still see a lot of people using it on the client. So, I don't know if you've ever gone to your dentist's office and kind of leaned over the counter and look what software they're using. A lot of the systems like that that are built into kiosks that are kind of, running hotel billing systems and other, admittedly non-sexy but very, very important things like that are actually written today using Java. So how do we think about evolution of Java? Well, I think that about 10 years ago, there was a pretty accurate perception that things weren't moving ahead very quickly. And I think this is a fairly normal thing that a lot of technologies experience in their growth curve, where, in the beginning, you're moving really fast, you're adding new stuff, everyone's really excited. And then, people have actually built a lot of systems on this technology. And so it becomes a challenge to continue to evolve it without breaking everyone out there. And different communities make different choices. Everyone has to make the choice that's right for them. But for Java, our choice has always been to err on the side of not breaking people, right? We try to make sure that when we put out a new version, code that is out there will continue to run smoothly. Now, sometimes that doesn't happen. I think one of the things that we've seen over time, and I'm going to talk a little bit more about this later, is that there's a tendency to look at the code and the APIs and sort of say, well, anything that's there is fair game. And Java is actually one of the few technologies out there that's been extremely diligent over the years about saying what is in the spec, what is the specified API, and saying if you keep to the specification, we won't break you. But we have to be able to change things that we consider internal implementation details. And because of certain characteristics of Java, it's actually been possible to call code which wasn't part of the spec. And typically, that's where code that has had problems in upgrades, that's where most of the issues have actually come. And so that's one of the reasons why more recently in version 9, which came last September, we introduced a module system which provides a facility for encapsulating internal implementation detail so that it's very, very clear to you as a programmer what is spec that you can rely on and that you should be calling versus something that is internal and you probably shouldn't be calling. Now, there are ways to get around and actually make calls to those things, but I think it makes the contract between the provider of a library, like the ones in the JDK, and the user far, far more intuitive. And in fact, this is something that you can use yourself. I think we built this in part because we wanted to have it for the JDK. We also built it so that people who are writing libraries or frameworks would have it available. And that includes people who may be using those and then providing code that's used throughout their organization. So anyone ever seen that? You wrote a library and someone down the hall started using it and then you did an update to it and then they came and got angry with you because you broke them? Right, and you're like, but you shouldn't be relying on that. I said I could change the order of return of return variables at any point. And they're like, oh, I didn't know that. So anyway, we'll talk about that a little bit. I think what we've been trying to do now is make sure that, oh, I went forward and I meant to go back, sorry about that. That as we're evolving, we're doing it in a way that's responsible. We're doing it in a way that doesn't cause unnecessary breakage. We're making it clearer all the time what things you can rely on and what things will evolve. We're generally careful about putting things in because when we've put it in, it's going to be there for 2 decades, right? So we would rather not put something in than put something in that turns out to be completely wrong and everyone hates. And we have done that in the past, so we know what that looks like, and it's not something that anyone likes. So basically, we try to be careful with that, and in fact, the approach we're taking with that is to do these projects in OpenJDK where we can test out new ideas, we can get feedback, you can try them out, you can tell us what you like, you can tell us what you hate, and then basically we make decisions after the fact about whether to put something into a release. Increasingly, we see people running Java in the cloud. This is kind of interesting because I think a lot of people think about other technologies when they think about cloud native and new workloads for the cloud. But the reality is there's tons of Java running in the cloud. And I think if you go and look at all of the cloud providers, you'll see that they're doing as much marketing as they can, and not all of it all that subtle, about why their cloud is a great place to run Java workloads. Okay, here I talked just a little bit about some of the areas that we're thinking about in OpenJDK, so that you can kind of understand. We've got these mystical project names, and I'll say a little bit about a couple of them at the end. But basically, these are what they're about, right? They're about improving productivity. They're about increasing density. That is, how much can you get running in the same amount of computing power? Improving startup time. Anyone want us to not improve startup time? Yeah. And not only startup time, but warm-up time. Improving predictability. GC is always an area that people find challenging, and so we're trying to make it be kind of as out of your way as it possibly can be and as predictable as it can be. And then also helping with serviceability and profiling. And I should mention that behind all of this, security is our number one. So we are always looking at ways of increasing and improving the security of the Java platform, and making it possible for you to make your apps secure. And that includes things like keeping up with latest crypto standards, providing things like implementations of new versions of HTTP and TLS and all that good stuff. So anyway, that also extends to things like trying to make sure that reported vulnerabilities are dealt with extremely quickly and effectively, to which effect we have quarterly updates. Okay. And speaking of updates, I'm going to talk a little bit about the new release model. Anyone not heard that we have a new release model? Okay, a couple of people. All right, so this will be new. That's okay, that's great. It's got to be new for someone. And for the rest of you, hopefully this will be something that kind of goes through and clarifies. It may be things you already know. There may be some stuff that feels new. So first of all, let's look at what the release model looked like before. Historically, Java has been on about a 2-year cadence of major releases. And typically the way this looked, and keep in mind, this is from the mid-90s, right? So at that time, that's kind of how software was delivered, right? At that point, you were lucky that people were downloading software and not asking for it on a tape. Just kidding. But no, it's true, actually. It is true. In any event, what tended to happen in this kind of model was you would need to decide about a year before your 2-year cycle started what was going to be in that release. And you'd typically have sort of executives from on high saying, oh, team, what are we going to have in this release? And we want to start marketing it. And you're like, oh, God, it's like 3 years. Are you serious? But anyway, they wanted to know. And then you would come up with a bunch of stuff that you thought might fit. And then they would start marketing it. And then you would start to work on it. And you would figure out that you really didn't understand that problem that well. And this other problem came up that was actually kind of more important. And things always got kind of squirrely. And typically you found that you might actually have to make some changes. Well, let's keep in mind here, let's look at this, right? We've got these overlapping releases every couple of years. And in fact, you didn't only have those because you typically would have about every 6 months some kind of minor update that was going on. And minor updates were often needed because these big 2-year releases had so much in them, and you didn't really, because this was all like proprietary stuff back then, you didn't really have a way of getting great feedback aside from a beta program. Everyone remember those? Of course you do. It's what Gmail was until like a month ago. No, seriously. No one got that joke? Really? Come on. Okay, so what's wrong with a beta program? Well, typically a beta program would work like this. About 6 to 4 months before your 2-year release was going to go out, you would send out a beta. And then if you were lucky, some people would try it, and it would take them some work to actually get anything going, and then finally they found something they think's a bug, and then a week, then they get called into a meeting, so it takes a week for them to report it. And then by the time they've reported it, and you've triaged it, and you've looked at it, and you've tried to find a solution, you're basically like a week before your thing's going to release, and nobody's going to let you put a change in at that point. And so typically betas almost never resulted in fixes to issues that people reported against the beta. And so that wasn't very good for anyone. So we kind of moved to a model with OpenJDK about just over 10 years ago, which has actually helped in doing multiple EA builds We currently do weekly EA builds during the entire life cycle of a major release. So you can go now and you can download the latest EA build. In fact, Jonathan told me that he did that recently, of 11, and you can look at what's there. And when you report bugs on that, typically, the amount of change in one of those is fairly small, so the ability for you to keep your code running on it it's not that much effort. And our track record in fixing bugs against that model is far, far better, because typically you find, you hear about a bug much earlier, and you have much more time to get a fix in. Okay, so in addition to those, I'll give you an example. This is theoretically what it would have looked like if we had stayed on a 2-year model, going from 8 to 9. So previously those were called U20, 40, 60 for reasons I won't go into. Take my word for it. And then with the numbering that was introduced for 9 and forward, it would be 9.1, 9.2, et cetera, et cetera. Now, what we have done as a change here, oh yeah, and this is the unfortunate thing that happens. You have a big feature you didn't know about, or that you learn more about and you realize it's going to take more to fix than you thought, then this is what happens, right? The entire release gets pushed out, but not only that release, but all the following releases for all time into the future, because not doing that, frankly, would be irresponsible, right? Releasing sort of something that was completely half-baked and caused issues is far worse than delaying. But it becomes hard to plan. If you're going to be a consumer of this technology, you want to know when it's coming. You want to know, when you should be testing and all that good stuff. So basically, we decided to move to a 6-month release model, right? So this is what 6-month releases would look like. And then we decided that that extra number was kind of funky and unnecessary because, basically we wanted to treat each of these releases as the same kind of unit. And what I mean by that, you can wonder, well, what kind of semantics are there attached to this major release number? Basically, for Java, what it has always meant is when you have a new major version, you rev the spec. You don't just rev the implementation, right? So there can be additional API added, as an example. In some cases, there can be API that's removed. Now, when we do that, we typically do it having warned you several releases in advance that something may go away, that it's going to go away here. Yes, it's now removed, but you may still be able to add it with a flag, and then it's finally removed. Okay, so basically, we have 6-month releases. We have the capability of doing spec changes within those releases. And then because nobody wants to be upgrading every 6 months, we provide long-term support, right? And so there's a certain one of these that's designated as LTS. And what that means is that you're going to be able to have something running in production and keep it running there, and the only updates you're going to have to do are security updates, and you're not going to have to worry about any changes to API or other stuff like that if you don't want to. So typically the model we expect is developers keep up with the 6-month releases because you want the latest stuff. You put something into production, and you want that to just run on a stable version and never have to change. Now you may have a workload that's different. You may have a cloud workload where you're updating constantly and you always want the latest even in production, and that's fine. You can certainly choose to do that as well. All right, so this is what it looks like in a larger context over more time. This is what it looks like if we overlay the existing releases, which can be looked at as long-term releases. I will point out JDK 6 is almost at its end of support life. So if you have something that's running on JDK 6 or earlier, you probably want to look at moving up. And if you're going to move up, you might as well move up to at least 8. And the good news is JDK 8 has many, many years of its support life left in front of it. So how many people are mostly running on JDK 8 right now? Yeah, that's kind of what I thought. That's good. 7? Anyone want to admit to 6 or earlier? Okay. And I saw your hand was up on a number of those, so I know how that can go. All right, I think that's fine. And what we try to do is give clarity and lots of warning in advance. So I'm kind of warning you in advance. Plan for 2025 when you're going to want to transition off of 8. Okay. All right, now a little bit of clarification here, because we've talked a little bit about OpenJDK, and I haven't talked about Oracle JDK. In the past, what you've probably been running is actually Oracle JDK, because typically the model, for the last 20 years has been Sun, and now Oracle provide the JDK as a binary under a commercial license. But wait, it's free, you say. Yes, it is. It's free of charge, but under a commercial license. What has changed, and we announced this at JavaOne last summer, is that Oracle has started producing binary builds directly from OpenJDK that we will release under an open source license. And so that's kind of what you're seeing there. So our model is the 6-month releases that you see going forward very rapidly. Oracle is producing OpenJDK binaries based on that and making those available. And then the Oracle JDK is sort of the vehicle for long-term support. And in the past, those were not exactly identical. Going forward, we're trying to make them exactly identical, and they will at least be interchangeable, okay? And you could wonder, why are they different? Very simply, in the past, we had commercial features that were added in the Oracle JDK, although it was probably about 90% just clean OpenJDK code. We've tried to push all of those commercial features into OpenJDK so that literally the only difference is one is long-term support and one is sort of moving fast for developers. And I'll show something on that in a minute. So this is kind of what your world can look like then. Oops, let me go back to that one. Basically, if you're developing, you want the latest, stay on the blue line up on top, move fast, keep updating. If you have a workload that just runs great in production and you don't want to take any risks, or maybe you want to, but your organization is averse to risk, you can choose support from Oracle or from other parties based on that, and have something that's just going to be stable for years and years, with, of course, regular security updates and with the ability to report bugs and get them fixed. Okay. All right, so this is the point I just made about there being OpenJDK binaries, right? And this is just a really brief list of those commercial features, previously commercial features that are now being pushed into OpenJDK. And that's kind of happening gradually over time. It's actually far more work than anyone could imagine. Open sourcing code that has been around for 10 or 15 years and is not yet open. So basically, the one, I'll talk in a minute about application class data sharing. Flight recorder mission control, if you haven't tried these out, please do. Those actually came from that JRocket implementation from BEA that I was talking about. And this basically is something that gives you really deep insight into what is happening in the VM and the choices that the VM is making based on its data, not some copy of its data that's been instrumented and collected, creating an extra layer of gunk between your application and the VM, okay? So, think about it this way. This is kind of like a black box recording, that you see in an airplane. That's what a flight recording is. That's why it's called flight recording. And then mission control is a user interface that allows you to analyze what's gone on. The problem this solves for you is, well, my server crashed at 3 in the morning, and I'm being asked why it crashed, and I have absolutely no idea. But I can go back and look at this flight recording and figure out not only what happened at the moment it died, or looking at the log and trying to figure out after the fact, but actually looking at what happened in the half hour leading up to that was where the cause of the problem happened. Extremely useful. Okay. So Java 9 came out last September. There's a long list of features that are in that release. Yeah, you can see it's long. The main one that people are aware of is the Jigsaw module system, okay? And I mentioned a little bit about this. I'm going to show you that this includes a number of different what we call JEPs. So a JEP is a JDK enhancement proposal. This is basically a small project or some kind of enhancement that somebody is proposing for the JDK. These are all in our bug system. They're open. You can go and look at them. You can read all of the text of who was it proposed by, what did they say, what problem were they trying to solve, what problems weren't they trying to solve, how did they plan to test it, all that good stuff. when you look at this, you'll see there are kind of a number of things we did. One was introducing a module system. The second one was using it to modularize the JDK itself. And you can see over to the right a small section of a diagram of the module graph that exists for the JDK class library, right? And then you can see a neat thing here. If your application depends, so your company application is up there in green, and it's depending on a couple of modules, but those modules in turn are depending on a few other modules. Well, before it was very hard to figure out what your dependencies were. Now with the module system, it's very, very easy for you to find out exactly what you're inadvertently depending on, and also what you're not depending on. And the reason that's interesting is because what you now can do is create your own runtime that has your application and the parts of the JDK, and only the parts of the JDK, that your application needs. So that's kind of cool, right? That makes things smaller, of course, but even more importantly, it can make things more secure. And the reason it makes things more secure is things that may have been, vulnerabilities that may have existed in some of those other modules that you weren't using but were carrying around might have been able to be exploited. And now they're not there, so they can't be. You've effectively kind of reduced your security surface and contained it to just the things that your application needs. It also allows us to do things like smarter ways of detecting when somebody is calling across boundaries that they shouldn't, by basically being able to see when someone is reaching inside another module. I won't go into how this was done before. There's been a story for this for years, but trust me when I say that the way it's done with modules is just inherently more secure. It also makes things easier for compatibility for upgrades. And what I mean by that is, again, you now know if your application is reaching in and using something that's not guaranteed not to change, right? So, you may be okay with that, but at least, if it changes, you're not going to be surprised because you kind of knew that, yeah, I knew I was using that thing. I shouldn't have been. Okay. And so it's easier for you to, basically, for us to maintain the JDK, for people who are making libraries to maintain those libraries, for your use internally, it makes your life easier. And that's a good thing, right? I think that helps us all move more quickly, and it's one of the reasons why, frankly, we feel that now after 9 was the time to move to 6-month releases and not before that, because we think after when we're all living in a modular world, it will be far easier for people to update more rapidly. Okay, another one of the things in 9 and future, there's some work on ahead of time compilation. So this basically is, now that we know which modules you're going to use, it's actually possible to add an installation step where now we know what hardware and operating system you're running on. It's possible to actually do some ahead of time compilation so that startup is faster, because typically for a JVM or a Java application, the first thing the JVM does is starts up, and then it starts to load your application, and that results in a whole lot of class loading going on. And then those classes are initially interpreted, and then over time they're compiled once it figures out what the hot paths are. And that whole process, both from startup and then warm up to running at kind of full optimized capacity, can actually take quite a while. And so what ahead of time compilation does is it allows you to analyze one of these startups or a group of startups and figure out what's the end state I'd like to get to, and then sort of essentially dump the contents of that so that the next time you start up, all it has to do is memory map that, and boom, you're running at full speed. So that's pretty cool. We've really just kind of scratched the surface on this. There's been a lot of work done, not only by Oracle and OpenJDK, but kind of across the industry on this over the years. And I expect we're going to see a lot of work on this, especially for workloads that are fairly small, but you want to have come up quickly. So if you think of something like microservices, where you basically want something to come up quickly, do something, then go away, this is the kind of technology you want, rather than the sort of traditional legacy Java technology, which was really about, okay, it's fine that it takes half an hour for me to get up to full speed because I'm going to be running for a year, right? If you're running for 30 seconds, you want something different. Okay, we've done a bunch of work for containers. Obviously, this is extremely important technology for the cloud. There were some issues with Java in sort of previous versions where our interaction with the operating system wasn't necessarily aware of the latest technologies that containers were using to say what resources were made available. So we've done a bunch of work. We're going to continue to do a bunch of work here, right? And we think that actually Java is a great technology to use together with containers. Oracle internally is using it a lot, and so I can tell you we're investing a bunch here. Okay, I'm going to mention this quickly, a little bit about browsers, because I know there are some people who care about Java in browsers and the plugin a lot, and are somewhat upset with us that we've sort of said we think that the plugin is not the way of the browser plugin is not the way of the future. Anyone think the browser plugin is the way of the future? Yeah. Nobody says, so I don't have to convince you guys. Good, you all pass. Quite simply, the really complicated thing there is that on the browser, it's not just about Java and the browser or Java in your application. All three kind of have to work together and kind of agree on how they're going to do that. And the large problem we've seen really over the past 5 years is that the browser manufacturers have decided they don't like the plugin APIs, and this is not about Java necessarily, it's just about, in general, it's very difficult to keep secure. And so this once standard API, which browser manufacturers supported, they've increasingly not supported and replaced it with typically not something standard, so their own kind of API. And that really sort of makes it impossible to have a good long-term story for applets running in browsers, because you're going to end up having to make everything different anyway. And so what we've decided to do is, talking a little bit about the custom runtime idea I was talking about before, figure out a way of making it so that when you have an application that you want to deploy, you can bring your Java with you. Okay, so rather than relying upon there being a standard Java in a known place on everyone's desktop in the world, right? You can make a self-contained unit, which is your application plus the parts of the JDK and the JVM that it needs in order to run. And the tool that you use for that is called JLink. If you haven't checked this out, please do. This is the thing that will let you create that custom runtime, and then basically make it so that you can have multiple different versions, each application running exactly on the version that it needs. Now, this does make a change for you, right? As a developer, rather than having the convenience of deploying to a website and knowing that people would go and point their browser to it and they would just get the latest version, you now need to think about how you're going to deploy to your users. But this is actually a problem that I think is largely solved, and it's been solved differently in different environments, typically by things like app stores, right? So we're seeing increasingly on different operating systems, each one providing their own app store, and users expecting to interact with that. And so if you choose to do something different, you're probably doing something that's unexpected and not what your users want. Okay? So here you can see those custom runtimes have been shrunk down magically by JLink in 9. All right, as I mentioned, there are a bunch more features in 9. I've really mostly touched on the module system, but as you can see, there are many, many things there, small and large. So I forgot to ask when I was asking about versions, how many people are using 9? All right. How many people are using 10? Define using. That was good. I'll take that as a yes. How many people have tried the EAs of 11? There we go. All right, good. So I guess we know what you're all doing tonight, right? Okay, cool. All right, I'm going to mention a couple of other projects that we have open sourced. One of them is called ZGC, and this is a very low latency garbage collector for very large heaps. And so this is, if you have an application that looks like that, you might want to check it out. It's actually very, very impressive in terms of the low pause times that it can get, and above all, the predictability of the pause times. And then, let's see, also, oh, I thought I had another one on there. I don't. Go back. let's just go forward. Okay, so Java 10. This was released in March, so pretty new. It is the upgrade path from 9. So just as before, if you were on 8 when 8U20 came out, you would go to 8U20. This is the same thing, right? If you were on 9, now 10 has come out, so you go to 10, and the support security updates are based on 10, not on 9. It can be confusing because you think of it as a new major version. On the other hand, if you think of it as this is just improvements on 9, 6 months worth of improvements, the only difference between 9 and 10 versus 8 and 8U20 is 10 may include some API improvements. Okay. So let's look at this. So I showed you that long list of projects that were in 9. Now remember, 9 was originally intended to be 2 years, ended up being actually a little over 3 years. And so basically, in 10, which was only 6 months in duration, there were 12 of these projects. So a lot less change, and that's good. And the thing to note here is that this gives us the capacity of taking some smaller projects that before would have been kind of a marble stuck behind a basketball, right? And what I mean by that is, you got this big basketball coming down the tube, and you've got a bunch of marbles, and the marbles can't get through because the basketball is in the way. Instead, we're able to get these smaller projects out and into your hands as a developer much more quickly. And I think that's generally good for everyone. Now, it doesn't mean we're not doing larger projects, right? It just means that the larger projects are not early bound to a release, such that if there's a change in the project or it takes longer than we thought or something else happens in the world, we have to delay the release as a whole, right? There will be a release every 6 months. What's going to be in it? I don't know. Ask me 3 months before and I'll tell you what made it in. What makes it in? Only the things that are done, right? So people are not, what we're trying to do is create a culture in the OpenJDK community where people know that, you don't come along and propose something to be moved into the mainline and thus the next release unless it's really done, right? And so I think that's working very smoothly thus far. And what we've seen is that from these larger long-term projects, you get these sort of pearls of small improvements that come out from time to time and do make it into the release. And an example of that is local variable type inference, which is a big fancy name for a var keyword, basically, right? So what does this do? It basically reduces the amount of boilerplate that you as a developer have to write. Now, if you're saying create a new one of these, you no longer need to declare the type of the variable on the left. It will be figured out for you by the compiler. Does this mean we're throwing away type information? No, we're not throwing away type information. We're just figuring it out because it's obvious, and we're not making you type it. So that's pretty cool. Can it be used for good things? Absolutely. Can it be abused? Yeah, probably that too. If you're interested in knowing the difference, I would recommend that you do a quick internet search for Stuart Mark's local variable type inference style guide, where there's a great document where he's really kind of explained the difference between where you should use var and where you probably don't want to. Okay. Oh, and application class data sharing. This was actually the first on that list of closed commercial features that we open sourced. This is pretty cool. This basically is something that allows you to take not only the class data of the JDK and create a shared library, but also class data from your application, right? And then that class data can be memory mapped, which means your startup time is much faster. All right, so 11. What's in 11? Again, I don't know. I'll tell you in a few months. Basically, what we've seen is thus far there are 4 JEPs that have come in. We expect there'll be a bunch more. It'll probably be about the same size that 10 was. And this page at OpenJDK, you can go and watch to see things as they develop in real time. So when new JEPs are targeted, they will be listed here. You can also do a search yourself and sort of look at what are the JEPs that are currently at which state. So is it something that's a wild idea way out in the future? Is it something that's a candidate that people are working on actively? Is it something that's actually being proposed to be targeted for an upcoming release? Okay. I'll say just a couple of comments about areas that we think are very interesting for the future. We've always, felt with Java that one of the main jobs that we do and benefits that we provide is insulating you as a developer against changes that are really challenging to deal with. And what I mean by this is we talked, initially about write once, run anywhere. Right? So you just wanted to write your application and you wanted it to work all over the place, and you didn't want to have a team as big as your product development team that was doing nothing but porting to different operating systems and windowing systems. Okay? Well, we've solved all of that with the browser, right? Okay, maybe not, but in any event, there's another kind of change that's important, which is change towards the future, right? So basically, we do an immense amount of work, and we do it together with operating system and hardware vendors to make sure that as new versions of their stuff comes out, Java is ready for it. And not only ready for it, but takes advantage of the improvements that are there. So as an example, we have folks from Intel and ARM and other vendors who do a lot of profiling work. They do it with early versions of their hardware in order to make sure that their design is going to run Java workloads well. And in some cases, that means they change their designs. In some cases, it means that we change Java and make improvements to new versions of Java so that when you eventually, or your customer is running on one of those new bits of hardware, your stuff just runs great, and you haven't had to update your application at all. And that, I think, is pretty cool. But one of the areas we see changing over time is focus in different areas of improvement. So as an example, 20 years ago, a memory allocation or a memory access and a CPU cycle were roughly about the same cost, right? Now they're vastly, vastly different, right? They made like lots and lots of improvement on the CPU side. The memory access, not so much. And in fact, what they've done is a bunch of hacks and tricks in order to try to actually make it so that memory can be local to the CPU that now is going so fast that you got to feed it really quickly, or you're going to spend all of your time not actually taking advantage of that faster CPU because you're still trying to get something out of memory. Now for Java, this has traditionally been a challenge because we had two types of data, basically. We had primitive types, right, which, like int and long and stuff like that. Those things were super fast, right, because they basically were native types. And that meant that all the low-level stuff that's done in order to take advantage of hardware optimizations is done. When you looked at objects, however, they were immensely flexible, right? They give you all kinds of cool stuff like identity and polymorphism and these wonderful object-oriented things. But they were typically a mess in terms of dealing with large collections and doing operations on them really quickly in modern hardware. And so what we're doing is Project Valhalla, which brings value types to Java that basically gives you a way of saying, I'm willing to give up a little bit of flexibility for an object in order to say it's immutable, right? And it's not polymorphic. So it basically is a complex type of what is essentially primitive data. And what that means is that the runtime can then do smart stuff, like rather than having pointers to these objects all over the heap and having to know that at any time the garbage collector may move them around, right? It can actually flatten those collections out, put them in line, make sure that they're fed directly to the CPU in a fast loop that's been optimized so that basically everything just fits nicely into a cache line and you're never waiting on a memory access. So that's going to be really, really cool. Check out Project Valhalla. Other areas we're working on, interoperability with native. We talk with the folks who make Hadoop and Spark and other cool things like that, Kafka. This is an area they care about a lot. Project Panama is where we're working on that. And we also have something called Project Loom, which is basically working on fibers for Java. So this is sort of the next level in having extremely fast parallel operation in Java. Okay. So basically, just to summarize, we've done a bunch of changes in the last year. They've really kind of surfaced in the last year, but we've been working on them for the last 5 or 6 years. And this has all been about getting us to a point where we have a platform which can move forward rapidly with 6-month updates, regularly getting out new things, but staying true to our ideals of making sure that we've got a strong compatibility story, a strong security story, a really easy way for you to kind of distinguish between I'm a developer, I want the latest, versus I'm running something in production, I just want it to be stable. And hopefully I've also given you some tips on where you can look in order to really kind of understand where the platform is headed, and ways that you can look at those things and give us feedback and get involved. So thank you all very much. And do we have time?
I guess we're running a little bit low on time, but we will go through a couple of the questions that were submitted via the app.
Okay.
The first question asked was, what value does Java certification exam add according to you? How does this new release model affect this?
Yeah, so I think Java certification exams over the years have kind of been what you and your potential employer make of them. You know, they are a great way to make sure that you're getting comprehensive education on the stuff that is in the platform and things that are new. Some employers, you know, care about this a lot. Some of them don't care at all. And so I think you have to look at your situation and what you think is right. We work very closely with the team that makes those exams. We also work closely with all of the people in the industry who are authors and publishers to try to make sure that there are great books out there. And typically we've seen that this has been good and is just getting better because there are some just fabulous Java authors out there. And in fact, you know, they tend to get the books out just as the new release is coming out, and the transparency that we provide in OpenJDK, I think, has helped a lot with that. Because, you know, it's not something in a dark room that's going on that they have to deconstruct after the fact. It's actually something they can see evolving.
Right. Yeah, there's lots of questions here, so I'm going to have to cherry pick.
Okay. Pick the good ones.
The next one is, so there are no more minor or patch versions. Are patches, security bug, only going to come out every 6 months?
No, thank you for asking that question. It's a very good one. There will still be quarterly updates. So we provide on a quarterly basis, second Tuesday of January, April, July, and October, security patch updates. And those are going to continue because, you know, as long as there are hackers out there trying to take us all down, we got to make sure that we're, you know, putting out fixes and improvements.
Here's a question that I would have asked you myself probably. When will we get a tuple in Java?
So the way that I'll answer that is, that definitely is something that people are thinking about, but rather than thinking about it as, when will I get a tuple in Java, the way we're thinking about it is, when can we have something like Panama that allows us to more gracefully write support for tuples in Java? Right? So we don't want to just give you a tuple, we want to give you something that's far more powerful that will support that and other use cases as well.
Yeah. So
if you ask me about tail recursion, I'm going to throw you off the stage.
I would have said, I would have asked you that 5 years ago, but I've been pestering Brian about it for a long time.
Good.
Here, the last one I'll read from the questions here was with ZGC,
yes.
Sorry, British. Do you plan to deprecate all other types of GC?
So that is a very good question. I would not say we plan to do that. I certainly wouldn't say that we plan to do it based on ZGC. ZGC is new. It's going to take years before it gets to, you know, a point where we're satisfied with it. We're still working on G1 and think it has a long way to go. It is far improved in 11/8 and in 8/7 in previous versions. If you haven't checked it out, please do. I do think that one of the things that's a challenge for any technology like Java that's around for, you know, a couple of decades is you tend to accumulate a lot of baggage. And so part of the problem then becomes, do you just have an ever-increasing surface area to maintain, or do you do some amount of pruning in order to be able to move more quickly, you know, and make sure the technology stays relevant? And so what we've tried to do is find places where we think that something has kind of outlived its usefulness. And on the Oracle side, what we tend to do is say, we're not interested in continuing to maintain this forever. If someone else is interested in coming along and doing so, and they're credible in OpenJDK, then, you know, make yourself known. And this is something that we did, for instance, recently with CMS. It's really been over the last couple of years. And, you know, interestingly, everyone was outraged that it might go away at some point in the future, and nobody wanted to actually take over maintaining it. And, you know, obviously that's a huge challenge with open source in general. And I think extra so when it is, you know, a base technology that's as broadly used. So, you know, I think that what we want to try to do is find the places where we can have more focus on fewer things, which ultimately it sort of simplifies things for you as a developer. Sometimes at the cost of some edge cases being harder to support. And we try to be very clear about it, and we try to talk about it very far in advance and not just sort of pull the rug out from under anyone.
So Little Bird just told me that we still got time for some more questions. So are there any questions from the audience? If not, I'll go back to the app. We've got lots and lots of questions in here. So that's a very technical looking question. I will try and pass it in a minute. Here we go. Will Project Valhalla value types support final references to objects or only primitive types?
Pass. I don't know. Oh, you go ahead then.
It does both. It will do boxing for you. So basically, the primitive types will be stack allocated, but if you need a context where you refer to it by reference, then it will auto box it for you.
Cool.
Yes. Next question. Okay, with its removal from the JDK, can you shed some light on what the future of JavaFX is intended to be?
Yeah, so I think this is one of these areas where there's great technology that we've spent a bunch of time and effort investing in to get it to a point where we feel that it's pretty good. And it actually, just so you know, like there aren't a lot of Oracle products that use it. And so as a company, we're going to continue maintaining it for quite a long time. It's it's in 8, so it's going to be maintained as long as that support lifetime of 8 that you saw there. But we really felt that for it to have a good, sustainable future, we need to encourage more people than just Oracle to invest in maintaining it. And so what we've essentially done is tried to sort of signal to folks that if you like this technology, if you're interested in it, there's an opportunity to come and get involved and help maintain it going forward. And this isn't something we should think should fall on any individual or small set of individuals' shoulders. It's something that we see a broad amount of interest for in the community. And so we're actively talking with people now who have said they're interested about what that may look like. So my expectation, based on the tremendous interest that I've seen, is there are all kinds of good reasons to believe that people will step up, and this is just what we want, right? An open source community that is truly open and has not just one big player investing, but a lot of players across the industry. I think it makes for better technology. It makes for more sustainable technology. And if you haven't checked JavaFX out, and your impression of it is from something that you saw in a demo 10 years ago, do check it out, because it actually is pretty stunning.
Okay, there are 2 more questions here. This one's about Jigsaw. How do you live in a hybrid world of some parts that are modules and some parts that aren't?
Yeah.
When should I work to update my library to a module?
Yeah, that is a great question, and undoubtedly one that we don't have time to answer in its fullness. What I would suggest that you do is go and look at some of the talks by Mark Reinhold and by Alan Bateman. There are a number that you can find online, and they're very, very good, and they talk specifically about this transition. What I will say is this: if our decision in making the module system had been to say, all right, this is it, we're going to have a module system, everyone's going to move to it on this day, and that's it, right? Then I think we wouldn't have a solution that it would have been a lot simpler for us, but we wouldn't have something that's as good as what we have. The current solution allows you to transition gradually. You don't have to use the module system in 9 if you don't want to. You can still use the class path. You can actually mix and match, and you can have some things that are modularized and not. Basically, what we've tried to do is we wanted to make sure that it wasn't an all or nothing proposition, because we realized that most developers are in a situation where you write a bunch of stuff yourself, but you also get a lot of pieces from other people. And so, we didn't want anyone to be stuck until, that one library that they rely upon is modularized in order to be able to move forward and get some of the benefits. And so, in fact, that's what it looks like. You can mix and match. I won't say it's simple, but it's definitely possible. And so, definitely check that out. And look at it as a way to transition gradually.
Excellent. So there's one more question here, which is very hard to read out loud because it involves Java syntax, but I'll try and paraphrase it instead. So if I'm assigning an array list instance to a var,
Yeah.
With type inference, will it translate it? How will it be translated by the compiler? as a list or always as the lowest possible interface?
I believe it does it as low as possible, but in bytecode. So definitely go and check out the style guide I was recommending. I'll say it one more time. Stuart Marks, Style Guidelines for Local Variable Type Inputs.
It will definitely infer an array list there, so the lowest type.
Yeah.
Absolutely. So that was all the questions in the app. So unless anybody has any more questions, don't be shy. No?
I'm here all day, so you can come and find me too.
Well, then let's thank George for a wonderful talk.
Thank you, Jonathan. Thanks, everyone.